Welcome to the Stormsurf video surf forecast for the week starting Sunday, April 28th. Looking at significant wave heights for the North Pacific Ocean, we see an area of, 26-foot seas off of North Japan, midway to the dateline, heading northeast. A little bit of swell production there. And another area of seas, probably in the 15-foot range, off of Northern California, all associated with high pressure and the usual summertime pressure gradient, producing wind swell only at the most exposed breaks, mainly north of San Francisco. All right, let's get into the details. As usual, we'll start our tour looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales do form, help direct their track. You're probably wondering why we're looking at the northern hemisphere and not the southern hemisphere, and that is because the southern hemisphere really isn't doing much quite yet, but that might be short-lived. So we'll take the last gasp look at the northern hemisphere before we probably shift south for the next 6 months. All right, so we have a trough. This is a trough right here, a dip in the jet stream, and that helps set up a counterclockwise circulation in the upper atmosphere, basically an eddy, and that's the hallmark of low pressure, and that also manifests itself down at the surface, and low pressure at the surface helps generate winds. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. And swell, when it hits your beach, produces surf. Right, so we have a little trough here, and it's only in the northern jet stream that you really look for the troughs. One here off of, we'll say, Kamchatka, and another nearly pinched off one with not a lot of wind energy. See, this one here has 130 knot winds in the apex of the trough, the bottom of the trough. This one, not even 80 knots or barely 80 knots, so probably not super supportive of gale development. And then you see when you have this split pattern like here, that produces high pressure, and that's exactly what we have off of California. High pressure in between the two flows, and that in summertime months actually produces wind swell along exposed breaks, mainly in central and northern California. All right, so a little bit of hope in one location, and we do know for a fact that there's something going on here because we saw in the significant wave height there are some seas there. So that trough is supposed to be productive a little bit longer, maybe into Tuesday it looks like or so, and then it fades out. This sort of trough here that moves into the Gulf, not very strong. Gets, 100 knot winds by Tuesday night into Wednesday. Cut off, basically what you call a cutoff low, because the main flow is up here doing this. This guy's sort of, and here's the southern branch, and he's just sort of stuck in between the two with no access to real energy. Maybe some weather for California when that trough moves in. All right, and then we get into, we're out to already Friday. Yeah, jet looks pretty good, but see, there's a trough, but it's extremely pinched off. Won't really help support much of anything. We get into Saturday, and we're just looking for anything, any signs of hope, and not really seeing it. And there we are, 7 days out. Jetstream, we think it's kind of split somewhere starting about almost at the dateline, with the southern branch going into Mexico, northern branch meandering across somewhere up around 45 north. Maybe there'll be a shot for weather here as we get into Monday, a week out, but the models change a lot that far in advance, so we're not holding our breath. All right, let's go take a look down at the surface. Here we are, surface level winds, surface level pressure, and no surprise, there's a trough here, and sure enough, there's low pressure with northwest winds, 35 knots. You can read it right off the chart there. That should be getting some purchase on the ocean surface, helping to produce swell, radiating somewhat at Hawaii, somewhat at the U.S. West Coast, but a long ways away, certainly from the U.S. West Coast. And if with a bunch of wind swell in the water here, you'd probably never see any swell from this system. So we'll say Hawaii is probably the best target. All right, let's put this into motion. See, that system continues to left north. The Aleutians are right here. Once the fetch gets north of there, actually, we're into Monday, still 35 knot winds. But there you go. By late Monday night, the fetch moves north of the Aleutian Islands. No swell can get south through the islands, and therefore the system becomes of no interest whatsoever. You also notice high pressure, 1028 millibars, the Gulf of Alaska, creating a bit of a gradient here. North winds at 15, 20, 25 knots off of Cape Mendocino. Good for some sort of wind swell of some kind. But then as we get into Wednesday, even that fades. You see low pressure, weak low pressure starting to build here in the Gulf of Alaska. Cutoff low. Here's another low. This is expected to develop off of Japan Wednesday night. At one point, it had actually, the models had suggested it getting semi-strong with 34-foot seas, but you can look at this, don't see any signs of that. You would need 40 or 45 knot winds. Here's a little patch of 30 knot on Friday night, and the lows just all stretched out and strange looking, not particularly organized. Here comes the next gradient, perhaps on Sunday. No, not even that. Maybe wind swell dying and staying small for California for a while. Here comes high pressure building as we get 180 hours out, but a long way from California. Good for trades for Hawaii. And we'll watch this here if this happens. Maybe with the high here, so the high rotates clockwise, the low rotates counterclockwise. When the low gets close to the high, it tightens up the isobars between them, and that generates wind. It'll get some 30-knot fetch out of this, but that's a week out. Don't believe it. So right now, North Pacific, not looking particularly productive, but let's go take a look at the wave model just for fun. And here we are. The low off of the Kuril Islands with 26.4-foot seas aimed off to the east. And that lifting north, still producing 22, 23-foot seas as we get into Monday night, and then it's gone. You can see the wind swell production, even that fading off of California as low pressure starts approaching the coast. Here's that next low forecast. Oh, now we have 21-foot seas. That's really going nowhere. That 21-foot seas, you'll get maybe a 12, 13-second period of that out of that, and that will be fully decayed, or at least not noticeable by the time it reaches California. Maybe dribbles for Hawaii with luck. You really need like a 16, 17-second period for a swell to be able to travel significant distances without decaying too much or losing much height. All right, and here we are, Saturday, Sunday. We're a week out, and just pretty much nada. No signs of hope. North Pacific, even a little tropical system suggested, probably won't happen. But there is something with the active phase the MJO develops as forecast over, actually it's right down here on the equator, pushing from west to east. That tends to help support tropical storm formation. So we'll see. We'll get into that in a minute. All right, let's continue our tour. Let's go looking south. So we're going back in time. This is Saturday, the 20th of April, last weekend. A system developed off of New Zealand. We're talking, this is the bottom of the barrel kind of system. What's that, 26, 27-foot seas? Okay. Lifting northeast a little bit, it faded, then redeveloped with a tiny area of 30-foot seas on Monday morning, and then that faded, and then it all started falling southeast and out of the California swell window. The point being, yes, there is likely some small swell in the California and even Hawaii swell window, mainly for during the work week relative to California. Nothing huge, but rideable. Probably the biggest swell we've had so far this summer, but that's not saying much. 2 foot or something like that. 2 feet at 16 seconds. In Southern California, so 3 foot, maybe a little bit more, maybe 3.5 foot. Best spots, when you get good refraction, get maybe another 25, 30% more out of it. Anyway, so then we're into Tuesday. Another system fell under New Zealand, but it was falling southeast of no interest. We'll just run this out, and there we are. Let's see, Saturday. There's really nothing. This little system was developing Saturday night, pushing north with 30-foot seas for a millisecond there. And here we are currently, maybe some swell from that, but there's more interesting things coming. So here's the current model. We're just going right to the wave model. Now this system is supposed to regenerate here in the southeast Pacific, and this is actually new on the charts with 30-foot seas aimed north. The deal on this one, very south angled, good for Southern California, but the point is it's up at 35 north or so, 36 south. That's a lot better than being down here. That cuts 1,000 or more miles off the journey up to California. That would mean less swell decay and maybe a little bit more size, but again, a small system. Now, the real interesting point is, here we go, on Thursday. Now, we'll watch this system under New Zealand. You need systems pushing off to the northeast, not falling south like this one here. So you notice we'll just show you here. It's falling to the southeast. Yeah, it's got 40-foot seas, but that isn't going to do much. Now, this system here, you can see, you can even look at the arrows, and it suggests the swell direction to the northeast and building with, what is that, 51-foot seas up to 52.7 on Thursday night, and then kind of moderating while tracking east. Secondary fetch, whoops, we'll go back there. What's that? Maybe 30, 32, 34, 36, 37-foot seas. Oh, it says 38. We'll say 37-foot seas. So if this thing were to materialize and then it fades out, one gets the sense there could actually be some not huge surf, but, longer period, 20-second period swell into California and energy into Hawaii. I haven't really looked at all the data, but odds are it'll be shadowed relative by Tahiti relative to California. But still, swell is swell. You take it where you can get it. I can't say enough that I'm already tired of the wind swell, and it's only been about 3 or 4 weeks since we've had legitimate swell into California. So we'll take it whatever we can get. This chart paints the situation a little bit better. It shows a whole 180 hours, all seas greater than 20 feet, all on one chart. And you see, basically, at some point in time, 30-foot plus seas are going to be over a pretty good chunk of the South Pacific over the next week. And there's your core of, what is that, yellow, 52-foot seas or so, something like that. So this is just a good way to get a snapshot of, is there potential or no potential? Sure. South Pacific, for the moment, looks pretty good. And this has actually been on the charts for 2 days now or something. So something to keep in mind, something to monitor. Next off, looking for wind swell. We'll say generally weather, but it's more about wind swell this time of year. So this is surface level pressure, surface level winds, 1036 millibar high in the Gulf of Alaska. Heat low building over Nevada. The gradient, the two competing systems close to each other creates a gradient. We have 35-knot winds off of Cape Mendocino. Now, one would say, and even if you look at the buoys up here, a pretty substantial wind swell pushing south. But once you get south of about Point Reyes, it's like from 330 degrees or something like that. So a lot of this gets shadowed as you get down into here and certainly into Southern California. So the wind swell isn't as big as one would expect even for, we'll say, the San Francisco Bay Area. Yeah, rideable, waist, maybe chest high, something like that. But that's about it. Anyway, roll this out. No real trades. You want to see a good size fetch, at least 15-knot trades for east wind swell for Hawaii. Again, gradient continues as we get into Monday relative to Northern California. 30-knot north winds off of Cape Mendocino up there. Sure, certainly wind swell. Then we get into Tuesday. Here comes this low here. And here's the high. It weakens and is starting to be influenced by the low. The gradient disappears. And as we get into Wednesday, wind swell should drop off and north winds should drop off as well. Too bad we don't have swell. High pressure trying to ridge into the islands gives you 15-knot trades, but over a very shallow area. Probably not any good for wind swell. Here's the low. It's fading. New high comes building as we get into Friday, 1030 millibars. We get sort of a gradient off Cape Mendocino, but not enough, and tucked up there right close to the coast. Not doing anything. Maybe a little bit better odds as we get into Saturday. So it looks like, we'll say wind swell for California on Saturday. Hawaii, still kind of high and dry. No significant trades as of right now. As you get into Sunday, better odds for minimally rideable wind swell at exposed breaks, but nothing more. And then, theoretically, low pressure starts building in the Gulf a week out, but by then, I think our focus is going to be down south. Here's a quick look at precipitation, mainly for California. We're about done with this for the season. No significant snow expected, no significant rain. Maybe a little bit in drizzle, I think we'd maybe call it, for Southern California on Monday. A little bit of snow on the highest elevations of the Southern Sierra Monday night into Tuesday. That clears out. And then we're just looking. Here comes the low. This cutoff low was actually supposed to produce some real, semi-real precipitation into California next weekend. But you can see now it's maybe drizzle and a little bit of snow over the highest elevations Saturday. Mainly rain. And Sunday, that kind of continues, but nothing significant, and that's it. Here's the snow dashboard for Squaw Valley. We're talking 2 inches, a little bit on the 30th of April, and maybe a dribble on the 6th, not much. Snow levels. This is the more interesting part here. So there is a significant snowpack in the the Sierra right now. At Squaw Valley, here's the base of Squaw. It's about 6,200 feet. Here's the summit at 9,000 feet, like top of Palisades, top of Granite Chief Chairlift or Granite Peak there. And the red is above freezing temperatures. And you can see, actually, so what was it, a week ago, there was actually good corn snow. And the longer this holds, the better the corn snow is going to get. Eventually, it will melt. But you can see, yeah, snow levels or freezing level dips down a bit on April 30th into maybe the 1st, and then creeps back up for Thursday, Friday, Saturday, then Sunday and Monday into, Sunday and Monday, it creeps back down and then back up and really starts heading up. So if you're into going skiing, there's piles of snow. The corn snow is almost as soft as powder. A lot of fun. Nobody around. No lift lines. You got the choice. You can ride blown out wind swell, or you can go ski corn snow. Not a bad alternative, especially with nobody around. And a quick look at Mammoth. Yeah, about 2 inches on the, we'll say, the evening of the 29th. So what's that, tomorrow evening? Snow levels, they're a little bit higher, so it's still freezing up at the top, but down lower elevations, probably good corn snow. Haven't heard a report, but the people that live there are in the know. We'll just leave it at that. All right, let's go take a look long term. What's going on with the Bad and Julian Oscillation and El Nino? And of course, the MJO, when in the active phase, helps generate or help feed the jet stream, which in turn helps produce storms in the northern hemisphere in winter months. But it also helps produce storms in the southern hemisphere in summer months. It's doing the same thing, just the correlation isn't quite as tight down south as it is up north. So let's go take a look. As usual, we like to start looking at winds on the equator. So this is the East Pacific here. This is the West Pacific here. That's New Guinea there. It's the area from 5 degrees north to 5 degrees south in the West Pacific from 170 west, so just a little bit southwest of Hawaii on the equator. Draw a box in your mind right here over to New Guinea, right in there. So this is actual winds from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. But you can also get, this is 5-day average winds, so not a single day. So it kind of lags a little bit in terms of what's really happening, but gives you a good real-time indicator of what's happening without using models. This is down at the ground truth. So east winds in control over the equator the whole way into the West Pacific area, the area we call the Kelvin wave generation area right in here. It's also the area that we use for monitoring the formation of the active phase of the MJO. But it is anomalies, differences from normal this time of year. And these little arrows give us some indications there. See, it says anomalies. And winds are basically, we're looking for the east-west component of the wind. Nothing, maybe a slightly bit stronger here, almost southeast of Hawaii. And then definitely a shade stronger here in the Kelvin wave generation area, indicative of the inactive phase of the MJO. If you see westerly winds or westerly anomalies here in the Kelvin wave generation area, then that's a sign of the active phase of the MJO. So no signs of that right now. Darn. And here's the performance of the winds. So this is over the whole planet, right? From 0 to 0. Kelvin wave generation area between 135 east to 170 west, so between here and here. This is time down this scale, so you just sort of look between these two lines going up. And so in March, we had the reds are westerly anomalies, active phase of the MJO. We had some good swell in late March, early April. I think there was even minimal Mavericks Day there. Last day of the year, we'll say the first weekend of April, something like that. Then you see westerly anomalies started dying out, and here's where we are today. big patch of blue, dark blue, easterly anomalies, inactive phase of the MJO. The first one of these we've seen with any real magnitude in a year now, a year and a half, something like that. The good news is, yeah, it's been in place for about a week, and it has maybe another week to go. But notice it's going from 120 over here to 180, basically nearly out of the Kelvin wave generation area a week from now. And what's this? Westerly anomalies building into the western Kelvin wave generation area. So it appears that we're about midway through the inactive phase of the MJO, and from here on, things are only going to be getting better. And remember, the models suggested down in the southern hemisphere, things are going to start waking up about a week from now. So maybe it has some, the active phase of the MJO is having some positive influence. So here's another way of looking at the active phase or inactive phase of the MJO. The colors are reversed. So oranges, and these aren't anomalies, this is sunlight reflectivity off the ocean surface. They use the word outgoing long wave radiation, but just assume if you see oranges, that means a bunch of sunlight bouncing off the ocean surface, which means high pressure, which means the inactive phase of the MJO. See blue, that's negative anomalies. That means a bunch of clouds. That means low pressure, because the active phase of the MJO is basically a low pressure cell, broad and diffuse, and it's in we'll say the eastern Indian Ocean. Okay, so that's where we are today. It's where we are 5 days from now. But 10 days, a week to 10 days from now, look at this. Active phase moving from the Indian Ocean into the West Pacific, solidly in the West Pacific 15 days from now. So we're talking, about mid-May or so. Things should look pretty good. This should help start. This is per the statistic model now, mind you. But this model suggests, hey, maybe by the middle of May, the jet stream will be looking pretty good in the southern hemisphere, and that would be more favorable for storm development. The GEFS model, we'll see if we can do this. I can't quite get it there, but okay, close enough. You get the idea. We're trying to compare the two models. GFS model says, and this is a dynamic model, says basically the exact same thing. Maybe the active phase not quite as strong, but the inactive phase will be out of here in a week, and that leaves the door open for the active phase. All right, so that looks pretty good. Let's go look at more models. Phase diagram charts. All right, so this maps out the heavy dot. Okay, actually, you're looking, assume when you see this circle here, you're looking down on the North Pole, and the MJO is on the equator, travels from west to east. Active and inactive phase from the Indian Ocean, over the maritime continent, over the West Pacific, under the United States, across the Atlantic, across northern Africa, back to the Indian Ocean. And that's both of the active and inactive phase. So if the active phase is here in, what is that? We'll say the East Indian Ocean. The inactive phase is probably 180 degrees on the other side of it, or probably south of California, something like that. Maybe working its way into the Gulf of Mexico, something like that. Anyway, the forecast, this is the track where it's been. The good news is the further away from the circle, the stronger it is. So it's been just hanging here forever for a month. Very weak, doing nothing. Now, finally, the active phase is on the move. It's developed. It's moderately strong in the forecast. This, per the statistic model, is it to make its way into the West Pacific. Some of the branches here suggest weakly. Others suggest a little bit stronger. The dynamic model says basically the same thing, splits the difference, say moderately weak, but into the West Pacific nonetheless. That's 2 weeks out. The CFS model goes out a month. This is the 4-month view. I'm sorry, the 4-week view of the CFS model. Here's where we are today. Again, a whole plan on one chart. Kelvin wave generation area between these two tick marks. The Pacific actually goes to somewhere about right here. Anyway, and time goes down. So here's where we are today. The dotted contour, inactive phase of the MJO. The blues are easterly anomalies. We've talked that before. The good news here, so that's a week tick mark. A week from now, you can see that the solid contour is the active phase of the MJO, working its way into the Kelvin wave generation area, we'll say, maybe even 4 days from now. And a week from now, getting pretty solid. 2 weeks from now, very solid in the Kelvin wave generation area, and continuing through the end of May. So May looks pretty good and pretty positive. If this materializes, that should help impart energy to the jet stream, both north and south, but given the seasonal issues, the North Pacific probably won't do much. Southern Hemi, this would be a big target to look for swell production. If you're doing a trip, something like that, middle of May, you might score. And then the 3-month view, same deal. So the tick marks right here going up. But this is, it switched the time scale. This is past history here. Here's a big westerly wind burst that has created a Kelvin wave. We'll get into that in the month of February. Okay, since then, you can just see we're looking for yellows or oranges. Pretty weak wind pattern in the Kelvin wave generation area right in here since March. And here we go. Here is our easterly anomalies, the blue. Now, the interesting part here is about a week out. Here, I would guess that this is supposed to be our active phase of the MJO with pretty brisk westerly anomalies forecast right mid-May. Let's overlay the MJO. Oh, surprise, surprise, there it is. Sure enough. Haha. Okay, now, the longer-term view, you get into May. Of course, in active phase, the dotted contour, it shows up. But westerly anomalies continue. Very kind of interesting. This is part of this hangover of El Nino thing, and maybe not even a hangover. It might still be there. And then you get into the next big window, I think, for storm production is in July, the 3 or 4 week window right here in July. Notice this is more focused in the West Pacific. This is more on the date line here. All right, let's overlay the low pass filter, see what we get here. All right, so this is the solid contour is an area favorable for low pressure development, or we'll say a low pressure bias, sitting right on the date line here. It was up to 3 contours. This is basically like a target saying El Nino, but not real strong because it was barely 3 contours, mainly 2. The third contour died. At least we have 2 contours now expected to hold into July, and then after that, that fades. So what this suggests is the peak of the El Nino thing was supposedly between February and April, but the seasons were already changing. And then from there, a slow fade. It does not look like any sort of a El Nino for the next year, but it certainly doesn't look like La Nina. The dotted contour here is high pressure bias. It's solidly in the Indian Ocean, but that's supposed to fade in about another day. Indian Ocean basically returning to normal. The Pacific Ocean still biased a little bit towards low pressure on the date line. Hopefully that'll hold into the fall. All right, let's take a quick look at subsurface sea temperatures. This is the West Pacific here, East Pacific here. We're on the hunt for Kelvin waves. That is warm water pushing from the West Pacific to the East Pacific. And they are generated by active phase of the MJO and strong westerly winds. And if you get enough Kelvin waves in a row, strong enough, that can help support the formation of El Nino. Unfortunately, we have not had enough. We've had enough to keep us interested, and keep us out of La Nina, but not enough to really get us into El Nino. And evidence of that, 29-degree isotherm here. This is actual temperatures, centigrade in the West Pacific, holding at about 170 west. That's where they've been. The 28-degree isotherm has made some progress. Most of the winter was hanging right around 160, maybe made some ventures over to 150 west, basically south of Hawaii. Now it's pushed to 115 west, so that means, when you see this isotherm line start moving east, that means it's probably a Kelvin wave in flight. 24-degree isotherm pushing into Equator. No signs of La Nina here, but only weak signs of El Nino. But it is the anomalies, differences from normal for this time of year. And what do we see? We see on the West Pacific, 1 degree above normal centigrade temperatures, and here's the 0 line the whole way across the Pacific. If we were in La Nina, the 0 line would probably be chopped off right here, and you'd see a big old ball of negative anomalies. Instead, we see plus 3-degree anomalies. This is that Kelvin wave that we were talking about that was generated in February by westerly winds here. They take the warm surface water, push it to depth. A ball of warm water works its way over 3 months the whole way across the Pacific, sitting right now at 120 west, due south of California, trying to work its way into Ecuador. Some of it's bleeding off on the surface. We don't expect a huge oceanic response from this, but maybe a little bit. Hard to say. Let's go look at another model. Here we go. Same data used as above. This is just modeled a little bit differently, but still you see the entire Pacific Ocean on the equator warmer than normal. Here's your pocket of your Kelvin wave right here. Warm anomalies pushing into Equator and up over the Galapagos, sort of bleeding to the surface, but not strongly so. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, 3 degrees above normal in pockets right here. Not a huge Kelvin wave in terms of, intensity, but covering a good size area. But we expect at some point this even over here will start fading out. Now, whether we'll go to La Nina, kind of doubt that, but maybe it'll just be a slow decline. Hopefully it'll make it through the winter. We'll find out in a minute. Sea level anomalies. This is from the Jason 3 satellite. Basically, you were looking for a bump on the ocean surface. The Jason 3 satellite beams radar down, or laser, I'm not sure which, off the ocean surface, looks for the reflection coming back to the satellite, and then times the difference. It knows what a normal trip is. If it comes back a little bit sooner, the ocean's higher than normal. If it comes back a little bit later, it's below normal, and it's very sensitive. We're talking centimeters here, 0 to 5 centimeters here and here. But this was 2 weeks ago. Pretty solid over this entire area. And what this means, so you strip out the waves, strip out the wind waves, strip out the tides, you see the bump on the ocean surface, and that means the inference is warmer than normal water at depth. Warmer than normal water, of course, expands, creates a bump on the ocean surface, but what we're seeing is the Kelvin wave is kind of dissipating. It's not even sure it's going to make it into Ecuador or the Galapagos. It just looks like it's kind of fading out in general, and it's only 5 degrees north and south of the equator here that really matters. So here's a historical look at what's going on. West Pacific here, East Pacific here. This is upper ocean heat anomalies, basically temperatures, differences from normal. You see warm water going from west to east over time. That was Kelvin wave number 1 back June a year ago. Kelvin wave number 2, much bigger, much stronger, in the fall of last year, erupted, but nothing, not a strong eruption. And these little pockets here, this is the upwelling phase of the Kelvin wave cycle. In between Kelvin waves, you get like cool water. Here's Kelvin wave number 3, and probably the final one, the strongest of all 3. Still, just not really having that much of a ocean surface effect as best we can tell. And it probably is fading out. Also notice the cooler waters here in the West Pacific, and we haven't seen that anywhere else, sort of suggesting the warm pool in the West Pacific is tapped out, and even if you got a strong active phase of the MJO, don't know that it could actually produce another Kelvin wave. So that sort of suggests the demise of El Nino, because there's no more warm water for the MJO to start pushing to produce Kelvin waves, and if you don't have Kelvin waves, you don't have El Nino. The question is, are we going back to La Nina, or are we just going to sort of go into a neutral pattern? The general sense right now is probably a neutral pattern, but we're going to find out a little bit more in just a second. All right, sea surface water temperatures, or anomalies, differences from normal. So you can see, here's Peru. You want to really see warm water building up here south of Mexico, all that. And it's been trying off and on in spurts, and then you get these cool upwelling phases, and here it comes again. Cool water building off of Peru. We know a Kelvin wave's like hanging under the surface down here, and we think this is the result of that eruption. It's not making it into Ecuador or Peru. It's kind of a westward displaced eruption cycle. So near the Galapagos and just west of there. The official El Nino monitoring region is out here, 120 west from 5 degrees north and south out to 170 west. So 170 is like up on this chart. You can see, yeah, temperatures are warmer than normal, but nothing like stark, obviously El Nino-ish. You'd want to see a big like triangle just blasting into here if it was some strong El Nino. We're not seeing it. This is minimal El Nino at best. The trend the last 7 days, okay, we thought the eruption was right here. But look at this. Blues are cooler than normal, or cooler lately than normal. A little bit of warming here off of Ecuador, but just kind of a very nondescript, nothing strong. Generic warming out over the equator in the mid-Pacific, but no strong El Nino signal, at least in the past 7 days. The overall pattern, so officially here's the El Nino box right in here, Nino 3.4 right in there. Yeah, water temperatures are warmer than normal. And from a backed off you. They're warmer than normal here along Peru and up into Ecuador. So some sort of a weak El Nino-ish like pattern, but not strong. Again, you'd want to see this big red triangle here. We're not seeing it. So, but it's better than a big blue triangle, which would be strong La Nina. Certainly way better than that. Here's the temperature trend in the Nino 1.2 region, the area right up along Peru, Ecuador, Galapagos, that area. You can see, yeah, there's been some spikes above normal temperatures. There's also been spikes below normal. These are probably associated with, either easterly wind bursts over there or upwelling phase of the Kelvin wave cycle. Today, temperatures dead neutral, 0.035. You can see the trend. You could draw a line through this and sort of say it's been downward, but it's corrected and stabilized right about 0 as of the past month or so. The Nino 3.4 area, the official El Nino monitoring region today, 0.560, and it has been steady, maybe dropping from 0.75 since early March, something like that, down to about half a degree. So El Nino is declared when you have half a degree water temperatures above normal for 5 consecutive months. Yeah, we've met that criteria, but part 2 of it is to have a real El Nino, you have to have an atmospheric component. We'll get into that in a second, but there hasn't been much. I mean, we all know that. This winter, was it great? No, it had its moments. There was surf. It was better than La Nina, but it was not off the charts. It was not even average, we'd say. Maybe on a 1 to 10 scale, it was a 4, 4.5. We were thinking it would be about a 6, but it wasn't even that good. Hard to know why. The weak El Nino is very hard to predict the effect on the atmosphere, but contrast to that is, yeah, but rain-wise, we did great. So 6 of one, half dozen of another. Take what you can get. All right, so what's going on in the atmosphere? We've talked about, the MJO and westerly wind bursts and Kelvin waves erupting or not erupting the way they're supposed to, and warm water in the East Pacific, which is good, but not particularly warm. But ultimately, and it's given us rain, but not necessarily surf. It's what's going on in the atmosphere that ultimately matters. One way to measure that is the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. When you have lower pressure over Tahiti, the index goes negative. When it stays negative for months and months and goes way negative, you have El Nino. If it's just weakly negative and kind of is cyclical in nature, sort of like watching there, that would have been the active phase of the MJO, and then it starts going positive. That would be the inactive phase of the MJO, and we're not sure where we are now. Let's go look at the numbers. Today, 0.86, so it's not really negative, not positive. Dead neutral, no MJO signal. But you can look back. You can see, actually, we had a long run of negative. It went for probably 2 months negative with just a couple little breaks in between. 30-day averages take some of the noise out of it, minus 2.75. We want to see this really down around minus 10 or 15. No, you look back, got down to minus 6.99 there in April, and it's been slowly coming up since then. 90-day average, we do this for looking for El Nino, minus 7.45. Not bad. You kind of look back, well, yeah, it was minus 7.55 a month ago. So we'll say a slight bias towards El Nino, but that's no different than what we've seen on everything else. The warm water, Kelvin waves, blah, 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 but just weakly biased towards El Nino. Here's the Esp Ai Index. So instead of difference in pressure between the area north of Darwin, Australia, and Tahiti, it's water temperature difference between this area and this area. When the index is positive, it means there's more warm water here. When it's negative, it means less warm water here. Today's value actually is April 23rd. Something's going on with the site or their data. It's plus 1.10, which is the highest I think it's been, it maybe got to 1.13 a couple days before that, like on the 20th. But the warmest it's been in here in 3 years, 4 years, something like that. So suggestive of barely weak El Nino conditions, but nothing more, not strongly warm. You can sort of see here Oh, I'm sorry. This is not temperatures. It's precipitation. Sorry. Precipitation differences. When you have warm water here, you get more evaporation. That gives you more precipitation. And I'm looking at the chart here and say, yeah, the greens are suggesting, greens and blue, more precipitation than usual. This is rainfall anomalies, but most of it is focused over here on the date line. You really want to see it down in here. We're not seeing that. If anything, we're seeing less precipitation than normal here. No big surprise. And finally, sea surface temperature forecast per the CFS model in the official El Nino monitoring region, Nino 3.4. So where are we? We're almost in May. Temperatures, according to this, about 0.9 above normal, but we saw in the other, they're really hanging somewhere down around here, so about half of what's predicted. The forecast as Kelvin wave number 3 erupts is temperatures to go up to, what is this, 1.3 degrees? That ain't happening, so maybe 0.75 or something realistically, and then slowly moderating as we get through summer and into the fall. Still, what's this, 0.9 or so, maybe probably about 0.4, and then slowly tapering off. So warmer than normal temperature in the Nino 3.4 area for probably through the fall into the winter, and then who knows where we're going to be after that. But hey, that's way better than cold temperatures. That's way better than La Nina. We'll take it. Weak El Nino dying to probably just a little bit above neutral by as we get into the heart right around Christmas time, something like that. So that would still favor storm development. Certainly wouldn't hamper it, but nothing off the charts. So for right now, we're betting everything on the MJO active phase building in May. That'll goose up the Jetstream. That'll feed the storm track. We've got a pretty good storm forecast for the southern hemi, a week out or so. And our expectation is there should be 2 or 3 more behind that series of southern hemi swells. If one believes any model going a week out, we don't. 3 days, 4 days the most. But hey, we're desperate. Sick of wind swell already, but hey, I'll take wind swell if that's better than nothing. And there's still corn snow in the mountains, and that's supposed to be hanging out for probably another 2 months or something if you can find a resort that's open. Squaw is, so that's good news. If not, then you go surf. Take what you can get, enjoy it. Things are looking pretty good, so we're happy. All right, so that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.